So in this session, we are simply going to look at, I'm going to answer 10 worked examples or 10 examination style questions on fractions and decimals. So before, of course, I get started with these questions and on these questions that I'm going to answer that are based from past paper questions, of course, I have to remind you that you're supposed to be watching these things with your pen and your book in your, right beside you with your calculator. Do not watch me just calculating these numbers. I advise that please, how you should consume this content is very simple. When I start a new number, if you feel you can do the number, try and do it on your own and get the answer you can get. Then after the answer you have gotten, then you can try and follow through, and see what I'm doing. And just to see, you play the video to see if the answer that I'm getting is the answer that you have gotten, like that. You keep doing that to all the numbers. Get to the question, pause the video, try out the number, see what answer you're getting. After getting your answer, play the video to see what answer I'm getting, see if we agree or not. That way, by the time you're done, you will find the video, the tutorial here, the video tutorial helpful to you. So let's get started with fractions and decimals. Now, we are being asked here to convert this to a fraction. Now, from here, you can see that this is what we call a recurring, it's called a recurring decimal. And the numbers that are recurring, they are 5.272727. So what we do here, we shall say let x, our value of x is going to be equal to 5.272727 and so on. Those are the numbers that are recurring. Now from here we shall go ahead and shift this decimal point, and we shall shift it two steps in front to there, to displace the number that is recurring onto one side of the decimal place. And for us to do so, it means we're supposed to multiply that by 100. So multiplying 100 on both sides here, we shall say 100x is going to be equal to 527.272727 and so on. After multiplying that, then we shall get this and we subtract, So we shall say 100x is equal to that, and then we shall bring back our earlier step. X is equal to, this is 5.272727 and so on. Then we shall subtract these two. When we subtract those two, 100x minus x is going to give us 99x is going to give us 527. Subtract that from 5, you get 522. Of course, when you subtract those, it's going to be 0, 0, and so on. So we divide both sides by 99, this will go with that. So we shall end up with our value of x here as 522, divide that by 99. So I think this can be divided further by 3. 522 by 3 is going to give us 174. And of course, this by 3 is going to give us 33. This also can be divided further by 3. By 3, this is going to give us 58. By 3, this goes plus 11. So we shall end up with 58 over 11. Now to prove, this is the answer, this is now the fraction, because they're asking us to convert that recurring decimal into a fraction. So of course, to prove whether you are correct, it's as simple. You simply have to punch this number into your calculator, and when you punch it into your calculator, it is supposed to give you back that figure. That's when you know that this answer is correct. Of course, here we are correct. So that's how we do that one. Okay, moving on to the next. It's the same thing here. They're asking us to express 0.341 whatever 6 in the form of P over Q, where Q is not equal to 0, so the denominator is not equal to 0. This is also another way of, expressing a recurring decimal. So from here, this is how it's going to go down. Now from this one, we can only see that the recurring decimal is the 6. The 341 is not recurring but the 6 is recurring. So again, like before, we shall say x is given by 0.341666. That's how it's given. Then from here, we shall first, put away these numbers that are not recurring. 341. Put them on one side of the decimal point, and that means you're supposed to multiply by, 1,000. So I shall simply come here and say 1,000x is given by 341.6666 and so on. Then of course after that, in our next step, we multiply by 10,000 so that now we include these numbers plus the one that is recurring. So meaning 10,000 is given by 3,416.666. So after doing that, like before, we get this and subtract. So in other words, it's going to become this step, which is 10,000. Let me rewrite it here, is equal to 3,416.666 minus the previous step, which is 1,000x, giving us, that is 341.666. When we subtract both, that's going to give us 9,000 is equal to 3,075. So divide both sides by 9,000. This will die with that. You shall remain with the value of x as, of course, this is the figure, but we are going to divide it by 5. This is going to give us 615. Divide this by 5. Subtract, divide that by 5. It will give us 123 by 5. This is divisible by 3. Gives us 41. By 3 gives us 120. And like that's when we have 41 over 120. Now when you look at 41, divide that by 20. If you punch that in your calculator, it will indeed give you our earlier expression, which is 0.341666. So that is how we, in so doing, we have expressed this number as just like the question required us to do. The question required us to express the number in the form of P over Q, and that is how we have been able to do it. Moving on to the next, so we are being asked here to simplify some fractions here. Of course, this is going to be, so let's get started with this. This is 3 whole numbers, 1 over 6, plus 1 whole number, 2 thirds. Divide that by 2 thirds, multiply that by 5 over 12. Now, there is such a thing called body mass, right? I think you've heard of it. So we have body mass here stands for, brackets. We do not have brackets of division. So we shall begin with division here. But of course, if we are dividing things here, we are supposed to be dividing this entire thing up here. Divide that by whatever is down here. That is what it means. So we can't divide, if you are to apply this division sign according to body mass, it is this divided by that. Now the issue here is that this whole thing is a component of small other things, even this one. So it means we're supposed to first resolve those things up so that we get one figure that we are going to divide all of a sudden. So it means this is going to become, so 3 whole numbers and 1 over 6, this is going to be, we convert that into an improper fraction. which is going to become 19 over 6 plus 5 over 3. Divide that by what is down here. It is multiplication. 2 times 5 is 10. Divide that by 3 times 12, which is 36. So this is going to become, of course, we are handling things from that level. LCM is 6. This 6 divided by 6 is 1. 1 times 19 is 19. Plus 6 divided by 3 is twice. Twice times 5 is 10. Divide all this by 10 over 36. So after doing so, we shall end up with 29 over 6. That is on top. Divide that by 10 over 36. Now that we have one figure on top and one figure at the bottom, now we can afford to go ahead and divide them like the way they should be. So this is going to become 29 over 6. Divide that by 10 over 36. And that is going to be equal to 29 over 6. Multiply that by 36 over 10. By 6 once, by 6 times. So this is going to be by 2, 3, by 2, 5. So we have 29 times 3, divide that by 5. And from there we end up with 87 over 5. And that's the answer to that question. So we have this one too. So let's first solve everything that is on top, solve everything that is at the bottom, and then we shall divide the two. So let's get started. So we have 1.5. Let's convert everything convertible here into an improper fraction. So 1.5, that is going to be equal to 2 times 1 is 2, 2 plus 1 is 3, so that's going to be 3 over 2 minus, put the big brackets there, 8 times 3 is 24 plus 1, that is going to be 25 over 3. Divide that by 2 times 2 is 4, 4 plus 1 is 5 over 2. So we get this and divide all that by, of course, 1 times 5 is 5 plus 1 is 6, so that is 6 over 5 of whatever is in brackets here. We are converting to improper fractions. That is 1, 4, that is 5 over 4 plus 5 over 3. We have converted everything to improper fractions. So we are now dealing with everything that is in brackets here. So it becomes 3 over 2 minus, so here you have 25 over 3, multiply that by, we find the reciprocal of this. So the reciprocal of 5 over 2 is 2 over 5. And of course, all this is divisible by or out of 6 over 5. Of, now 5 over 4 plus 5 over 3. Let's add those ones right now. So the LCM is 12 right there. 12 divided by 4 is 3. 3 times 5 is 15. Plus 12 divided by 3 is 4. 4 times 5 is 20. So of course this is going to give us, proceeding, 3 over 2 minus, now here is by 5 once, by 5, 5 times 2 is 10. So it's going to become 10, divide that by 3. All this is divided by 6 over 5 of, in brackets here, 15 plus 20 is 35. Divide that by 12, like that. So from there, we're able to see that this is going to be, now of course this is 3 over 2 minus 10 over 3. So 3 over 2 minus 10 over 3, LCM of 2 and 3 is 6. 6 divided by 2 is 3. 3 times 3 is 9. Minus 6 divided by 3 is 2. 2 times 2 is 2 times 10 is 20. So that is what is now at the numerator. Divide that by 6 over 5 of that. This is the same as saying, this is like multiplication as well. So by 5 once, and by 5 is 7. By 6 once, by 6 twice. So down here, what we have remaining is, of course, 7 over 2. Then from there, we shall proceed with negative 11 over 6. Divide that by 7 over 2. And so this is going to become negative 11 over 6. Multiply that by 2 over 7, by 2 once, by 2, 3. So we shall end up with negative 11 over 21. So negative 11 over 21 becomes the answer to that expression they have asked us to simplify. Moving on to the next. So again, we are asked here to simplify, and we are supposed to give our answer in a standard form, in the scientific standard form. Again, we are going to do the same here. We are going to break it down as much as possible. So we shall say it is 3 times 10 to the power negative 13. Multiply that by, now this is 6 times 10 to the power 5 squared. This squared means that this thing is multiplied twice. So let's expand it like that. So 6 times 10 to the power 5, multiply that by 6 times 10 to the power 5. That is what it means when they say squared. All this we shall say is over 80. So that being done, we shall simply come and say, now take note that 10 to the power negative 13. Let me give just a simple illustration here. Of course, I expect that you should be knowing this from your laws of indices. If I say something is 10 to the power 2, 10 to the power 2 means it's 10 times 10, which is 100. But if it is 10 to the power negative 2, that negative means it is 1 over 100. I think you know this law from indices. That negative spells the reciprocal of that number. So in this case here, if it is going to be 3. Multiply that by, now 10 to the power negative 3 is the same as 1 over 10 to the power 13. So we multiply that by 6 times 10 to the power 5. Multiply that by 6 times 10 to the power 5. All this, we are dividing that by 80, like that. So we continue with our working. So let's rearrange the top part. So this is going to become, of course, it's going to be 3 times, of course, times 1, times 6, times 6. Then we have times 10 to the power 5, times 10 to the power 5. Divide all this by 10 to the power 13. And of course, all this is divided by 80, like that. So from here, what we have is 3 times 1 is 3 times 1 right here is 3. 3 times 1 is 3. 3 times 6, 18. 18 times 6 is 108. So we shall come here and say this is going to be 108. Multiply that by, now this is 10. 10 to the power 5, then 10 to the power 5. From our laws of indices, when you are multiplying two numbers that are having the same base, you will maintain the base and you add the powers. So in this case, it's going to be more like times 10 to the power. When you add the powers, it becomes 10. This is, divide that by 10 to the power 13. And then let's say this is divided by 80. So we continue. This is also going to be, so 108. It's like saying 108 times 10 to the power 10 over 10 to the power 13. Divide that by 80. Now, again, the laws of indices, we have 10, the same base. So what do we add to the powers? we shall subtract them because we maintain the base and add the powers. It's a law of indices. So this is going to be 108. Multiply that by 10. You maintain the base and subtract the powers. So of course, when you subtract the powers, it becomes 10 minus 13, which is negative 3. Like that. Of course, this is divide by 80. Let me call that divide by 80. Let me put it like that, divide by 80. So of course, the rest becomes just cancel. So this becomes by 80 once, and then by 80, we are getting 1.35. So this becomes 1.35 times 10 to the power negative 3. So we have this number, we have it in part A and part B. We have part A here. We have a man, right there. The question says that a man gave half of his welfare allowance to his wife. So let's talk about, summarizing this question. We have this man, half of his welfare allowance, he gave it to his wife. So let's say his welfare allowance is equal to X. His welfare allowance is equal to X, right? So if his welfare allowance is equal to X, he says that the man gave half of his welfare allowance to his wife. So here we know that the wife got a half of that welfare allowance, which is X, right? So he gave half of his welfare allowance to his wife. I think that is pretty generous. Then a fifth to each of his 2 sons, and the rest to his daughter. So the 2 sons each got a fifth of that welfare allowance, and then the thing says, and the rest to his daughter. So what the daughter? It means that the daughter receives the rest. So meaning that if this is the welfare allowance, we're supposed to say that's the welfare allowance minus what was given to the wife minus what was given to the the 2 sons. Now remember what was given to the sons. We have 2 sons. The thing says a fifth to each of his sons. So meaning that this is a fifth. This a fifth is two times, yeah, because they are 2 sons. So he gives a fifth to each of his 2 sons. So each of his sons gets a fifth of the welfare allowance. So even here, as we are subtracting what the daughter gets, it is the value of X, which is the welfare allowance, minus what his mother got, which is a half X, minus what one of the sons got, which is a fifth X, minus what the second son got, which is a fifth X. So the answer to that calculation is what the daughters get. Okay, so that's what they mean here when they say that a fifth to each of his 2 sons and the rest to his daughter. And then they're asking, find the fraction given to the daughter. Now let's try and find the fraction that was given to the daughter. So for us to be able to get the fraction of the daughter, of course, this expression here is going to give us the fraction that the daughter got. So let's remember the value of X here represents the total allowance. So we shall simply come here. Let me write it here. This is going to become X minus a half X minus 1 over 5 X minus 1 over 5 X. Let's call this over 1 and then let's solve this whole thing at once. So this is going to become, the LCM here will be 10. 10 divided by 1 is 10. 10 that's going to give us 10x. Minus 10 divided by 2 is 5. 5 times x is 5x minus 5x. 10 divided by 5 is 2. 2 times 1 is minus 2x. The same thing is here. 10 divided by 5 is 2. 2 times x is minus 2x. And so definitely this is going to be 10x minus 5, which remains with 10 minus 5 is 5. 5 minus 2 is 3. 3 minus 2 is 1. So this remains with x on top over 10. Now remember we said x is the allowance, and the question here asks us that to find what is the fraction that was given to the daughter. What fraction was given to the daughter? So we shall simply come here and say that the daughter received a 10. of the allowance. Like that. So the daughter received 1/10 of the allowance. Then Roman 2, the question says that his welfare allowance, the question here says from here, find Roman 1, that's what we do. Then Roman 2, find his welfare allowance if each son was given 16,000. So if each son was given 16,000, remember each son receives, this is part B. Remember each son received a fifth of X, a fifth of the allowance. So we know that each son here got a fifth of X. Now, and they are saying that each son got an allowance of 16,000. So we shall simply come and say, so meaning that a fifth of the allowance that was given out is equal to 16,000. So from there we can go ahead and find the value of X, which happens to be the allowance of the man. So this is going to become a fifth X, giving us 16,000. Multiply both sides by 5. This will go with that. You end up with the value of X as 80,000. So our value of X there is 80,000, and definitely that is how much the man had. So if each son received 16,000, we've been able to find the welfare allowance. So in other words, the welfare allowance of this man was 80,000. Moving on to the next. Of course, express this as an improper fraction in its simplest form. Yeah, it is 3 and 6 that are recurring, so we shall simply come and say X is given by 2.36. Those are the numbers that are recurring. Then, of course, the recurring numbers are 2, so we shall multiply it by 100 on both sides. So shall come and say 100x is equal to 236.36. Then we shall bring the earlier step and we say minus x is equal to 2.36. When we subtract the 2, we remain here with 99x, giving us 234. Divide both sides by 99. This goes with that. We shall remain with our value of x there as 234. Divide that by 99. So we shall end up with simplifying that into its simplest form. I think it's divisible by 3. So by 3 here we have 78. By 3 here we have 33. That can be further divided by 3. When we do so, by 3 we have 26. By 3 we have 11. So we have 26 divided over 11 as our improper fraction. And of course, if we get that, if you want to test whether you're right, 26 over 11, punched it in your calculator, it should give you 2.36 recurring. Moving on to this one, pretty much like before, very obvious. One whole number and a quarter plus 2 whole numbers and a half minus 1 whole number, 3/2. Here we shall follow BODMAS. So brackets of division, multiplication, addition. So addition comes first, so that means that we're going to first have to add. So that means it's going to become, that is 5/4 plus 2 times 2 is 4 plus 1, 5/2, then minus. Of course, this is going to be 2 times 1 is 2, that is 5/2. So from there, we are going to add first because it's addition first. So we add first. So the LCM there is 4. 4 divided by 4 is 1. 1 times 5 is 5. Plus 4 divided by 2 is 2. 2 times 5 is 10. Minus 5/2. So this is going to become 15/4 minus 5/2. Now that the addition is done, now we can go ahead and subtract. And subtracting, we find the LCM, which is 4. 4 divided by 4 is 1. 1 times 15 is 15. Minus 4 divided by 2 is 2. 2 times 5 is 10. So 15 minus 10 is going to give us 5/4. And that's the answer to part Roman 1. So Roman 1, it is 5/4. So let's move on to Roman 2. So Roman 2, we have, of course, 2 whole numbers and a half. Multiply that by 3 whole numbers and 1/3. Divide that by 1 whole number, 5/6. So again, BODMAS, brackets of division. So it means we're going to first begin with the division part. So for that, we are going to let's maintain these, convert them to improper fractions. That's 2 times 2 is 4 plus 1 is 5. So that is 5/2. Multiply that by 3 times 3 is 9 plus 1, which is 10/3. Divide that by 6 times 1 is 6 plus 1 plus 5, 11/6. So let's deal with the division part. 5/2. Multiply that by 10/3. Then, of course, that is multiply that by the reciprocal of 11/6, which is 6/11. Now that things have been converted all to multiplication, then we can go ahead and multiply normally by 3 once, by 3 twice, by 2 once, by 2 5. So that means 5 times 5, which is 25 times 2, which is 50. So on top we have 50, divide that by 11, which is 1 times 1 times 11, which is 11. And that's the answer. So that is our Roman 2 for that. Moving on to this one, express 0.38 as a fraction in its simplest form. Same as before, we have a value of x as 0.38. We have a dot on top of 8, meaning it is only 8 that is recurring. So, of course, as usual, we are going to first bring this number that is not recurring onto the other side of the, on the other side of the decimal point. So by multiplying 10x, 10x is going to be equal to 3.8. It's 8 recurring. Then now, again, we are going to apply another multiplication where we're supposed to get both plus the number that is only recurring to one side. So that means you're going to multiply by the 100. So this is going to be 100x is giving us 38.8. It's 8 that is recurring, so it's the same as saying 8, 8, 8, 8, whatever. So of course we shall bring the previous guy and we shall say minus 10x is equal to 3.8 recurring. Subtract these two, get 99x is going to give us, subtract these two, get 35. Divide both sides by 99. When you do so, this will go with that. You shall remain with your value of x as 35/99. I think I made a mistake here with 90. Actually, 100 minus 10 is 90x, not 99. So this is supposed to be 90x. So this is 35/90. And the answer we have here is 35/90. Of course, 35 divided by 90, dividing that further by 5, you have 7. By 5, you have 18. So the answer here is 7/18. And if you punch that into your calculator, 7 divided by 18, it should be able to give you back, 0.388 recurring. So finally, doing the very last number. So we're going to do number 13a, 1.252525 as a fraction. Of course, this is like we have been doing before. So we shall say that our value of x here is 1.252525 and so on. Now, of course, the numbers that are recurring are 2 and 5. So because there are 2, we are going to multiply 100 on both sides so that we are able to move this decimal point to that place. So we shall come and say 100x is going to give us 125.2525 and so on. Then we shall get that previous step, and we say minus x is equal to 1.2525 and so on. When we we subtract, we end up with 99x here, going to give us 1 to 4. So from 1 to 4, we go ahead and divide both sides by 99. We end up with our value of x as, of course, this is divisible by 3. By 3 is, no, it's not divisible by 3. So it will just remain like that. It is 1 to 4 over 99. So we shall leave our answer like that as 1 to 4 over 99. That is sorted. So we have answered part A. So let's move on to part B. So moving on to part B, let's do it like this. So this is part B. Part B is giving us here this thing that a 2g minus e is equal to 3g into g minus e. And we are being asked to express g in terms of e in its simplest form. So in other words, they are telling us, if they are telling us to express g in terms of e, it's as good as telling us to make g the subject of the formula. So here we are having g all over. We have g here, we have g right there, we have g right there. And we are being required to make this the subject of the formula. So what we are going to do instead, let's first open up these brackets and make it, all clear. So this is going to become 2g minus e is given us, open brackets, we get 3g squared minus 3ge, like that. So let's try and move. Now you realize that when we said 3g squared, this g squared means that this expression is now going to become a quadratic expression. We know quadratic expressions have their highest power to be to the power 2, ax squared plus bx plus c, So if we are having an x squared somewhere, I'm seeing here g is 3g squared, so meaning that this is a quadratic expression. So what we're going to do, let's shift everything to one side, quadratic expressions are always equal to 0. So we shift all this that side. So this is going to become 3g squared minus 3ge. That is going to be minus 2g plus e is equal to 0. Maybe let me rearrange it here and say this is going to become more like 3g squared minus 3ge minus 2g plus e is equal to 0. Now when you look at this, remember, since we have g squared, that is going to become a quadratic. This is a quadratic expression because it has its highest power as 2. And so it means if we are to make g the subject of the formula, it is as simple as making this, this expression look like we are factorizing it. But I think this time we're going to factorize using what we call the bulldozer formula. What they call the quadratic formula. First of all, we know that quadratic equations are always in the form of ax squared plus bx plus c. So it means that the onus is on us to make sure that we rearrange this equation here so that it looks like the quadratic expression. After making it look like the quadratic expression, then we can go ahead and find the value of x. And in this case, finding the value of x will mean that we are trying to find the value of g, because here it is the g that will be our value of x, since it is the one that is attached to the square, 3g squared. So g is our value of x in this expression. And after doing so, we will be able to get an expression that, that satisfies the question. The question tells us that given that 2g is equal to that, express g in terms of e. So that's how it will play out. So let's proceed. So this is going to become 3g squared. Yeah, so we have 3g squared. So let's say this is plus. Let us try and factorize whatever is inside here actually. And from there we are having some g. Remember, we have ax squared. Our value of a here is 3. Our value of x squared here is g squared. So we are saying plus, and that's the plus. So plus we want to define value of b and value of x. Remember, x is the g. So from here we can put g outside the bracket since it is common here and there. So we put g outside the brackets in brackets here at this point we shall remain with negative 3e minus 2, like that. We have factorized how? It is negative 3ge divided by g to get negative 3 in brackets. Then we have negative 2g divided by positive g to remain with 2. That's how it has come out. Then this goes plus e is equal to 0. So if you look at this expression, let me rewrite it here. Let me just rewrite it. This has now become 3g squared plus, g into negative 3e minus 2 plus e. This is equal to 0. If you look at that expression, it is all in the form of ax squared plus bx plus c. And our value of x we said is g. So meaning that here, our g squared here is the x squared there. Our value of x here is the value of g here. Yeah. Then the value of c is the constant here plus c. Are we together? Then of course our value of a here, let me see, what color can I use to differentiate this? Our value of a is that. Then of course our value of b is that expression. Then of course our value of c is like that. Now we know that when it comes to quadratic expressions, something like that, we have, they call it the bulldozer method. Sometimes it's called the quadratic formula, where we have minus b plus or minus under the square root of b squared minus 4ac, divide that by 2a. This expression is derived from completing the square. That's how it is derived. I am not going to go into those details. Those were taught in your class. So when we are deriving the square, we come up with this expression, and this is giving us the value of x. When we are trying to find the quadratic equation, our value of x is given by that. Now here, since our value of x is g, now we can as well substitute in this. So we can simply come here and say, so meaning our value of g, which so happens to be our value of x, according to this expression here, is going to be equal to minus b. Now what's our value of b? I think you can see minus in brackets b, which is negative 3a minus 2, like that, plus or minus the square root of b squared. What is b squared? B squared is negative 3a minus 2 squared minus 4ac. So this is going to become minus 4 times our value of a. Our value of a, according to this, we can see our value of a is 3 from here. Our value of a is 3, so that is going to be minus 4 times 3 times our value of c is e. From here, you can see our value of c is e times e, like that. Then divide that all by 2a. That is 2 times a. So that is 2 times our value of a. From here, our value of a is 3. So that is 2 times 3. Well, this number looks quite tough, but well, that's an examination kind of question, and that's how examinations normally go. So meaning this is our value of g here is, now we are simplifying it. This, we have already substituted it into the bulldozer method, and now from here you can see that g has become the subject of the formula and the rest is here. So the rest is just simplifying it. If you have to open brackets here, this is becoming 3e plus 2 plus or minus under the square root of, we can leave that the way it is, minus 3e minus 2 squared minus 4 times 3 is 12e divide that by, I think, by 6. Yeah, and that's the answer. So by that answer, we have actually expressed, from what you can see here, we have been able to express, part B. We have answered part B. We have been able to express G in terms of E. And I think this is the simplest form we can go. So that's the answer right there. So that one required you to know, to be able to recognize that this is a quadratic formula and reshape the expression into the quadratic form, and be able to use the quadratic formula or the bulldozer method to be able to come up with that expression you're seeing. So that is part B. Let's go on to part C. Then this is the last question we are doing. Part C is there. Express that is a surd where A, B, and C are constants. So this is going to become square root of 4 plus square root of 3, divide that by square root of 4 minus square root of 3. Express this in this form where A, B, and C are constants. So with this, we do what we call rationalizing the denominator. These are irrational numbers, the way you're seeing. So we rationalize the denominator by multiplying this by its conjugate. So this becomes root 4 plus root 3. We multiply that bottom and the top, root 4 plus root 3. Now, what do I mean by rationalizing the denominator? What is a conjugate of a surd? I explain all those details in some lecture where I start with surds from beginning to end in their details. This is just revision, so I am doing this assuming that you have that background knowledge, you learned this topic in class. So I am not going to go so much into those details. So definitely, so we proceed with the working. So this, okay, this is root of 4 minus root of 3. Okay, so we go on and open brackets. Root 4 times root 4 is 4. Then root 4 times root 3 is plus, I'm opening brackets. Root 4 times, okay, let me move slowly to avoid confusion. So this is opening bracket, it's going to be root of 4 times root of 4 plus root of 4 times root of 3 plus, then we have root of 3 times root of 4 plus root of 3 times root of 3. All this, divide that by what is below. Now below, from what you can see, there is a trigonometry, there is an identity that we can use to make a shortcut. This is like saying a squared, let me write it here like, side work. We know that a squared minus b squared is given by a plus b into a minus b. From here we can see that a plus b is what you're seeing there. Then a minus b is what you're seeing there. Our value of a is root 4, our value of b is root of 3. So it means that this can be expressed in this form, a squared minus b squared. So it means the denominator here can be expressed as root of 4 squared minus root of 3 squared. This is coming from that identity. Again, I do not want to go so much in details. We are just doing revision, meaning that we studied the details of these things when these topics were being introduced to you in class. So let me try to wrap that off. So moving on, we are now working this down. So root 4 times root 4. When you multiply two roots, you end up with the same number. Let's demonstrate it here. If I'm multiplying the square root of 25, multiply that by the square root of 25. square root of 25 is 5. Multiply that by square root of 25, which is 5. 5 times 5 gives you 25. So realize that when you multiply two numbers with the same square root, you end up with that very number. In other words, square root of 25 times square root of 25 is giving us 25. So it's the same logic we are applying here. Square root of 4 times square root of 4 is giving us 4 plus square root of 4 times square root of 3 is going to give us square root of 12. Then also plus, this is also square root of 12. Square root of 3 times square root of 4 is square root of 12. Then we have plus square root of 3 times square root of 3 gives us 3. Divide all that by 4 squared. 4 squared is going to be 4. That is square root, the square of the square root of 4. This goes with that, remain with 4. Then this is minus. This goes with that, remain with 3. Of course, this is going to be equal to 4 plus this plus that is going to become 2 into root of 12 plus 3. Divide all that by 1. So, of course, this is going to be equal to 4 plus 3, which is 7 plus 2 times root of 12 over 1. Now, for you to be able to do surds, this is a whole topic on surds. There are some laws or guidelines that help you to be able to do the algebra behind surds. I have a whole lecture on surds from simple to complex on how it is done. Here we're just doing revision, so I'm not going to explain a lot of details. I'm assuming that you learned that in your class, you've just come here for revision. So yeah, that is going to be 7 plus 2 root 2. And if you look at the question here, you're saying that the question says, express this in this form of a plus b root c, where a, b, and c are constants. So from our answer, you can see that we have indeed expressed this thing as a plus b root of c, where our value of a is 7, our value of b is 2, and our value of c is 12. So this is the answer, 7 plus 2 root of 12. That's the answer. So that brings us to the end of this session on fractions and decimals. If there are any, of course, as we are doing this, these are examination kind of questions, and because they're examination kinds of questions, they tend to be high end, they tend to be intense. They are also a wake-up call to let you know on what areas throughout your curriculum that you need to concentrate on and practice more and understand more, so that you're able to do these numbers at a higher level. The concepts underlying that are helping us to do these numbers, for example, the concept here of surds, when you look at the concept of the bulldozer, the quadratic expressions, the factorization, these are simple subtopics that can be introduced to you from scratch, and you're able to understand them in their entirety. In case you find that some of these things are complicated and you feel you don't understand them, it has everything to do with the topic, the underlying principles. Maybe they were not explained to you very well, or you didn't understand them. It's just as simple as going back. Just have an open attitude, just go back to those concepts, those topics, sit down and watch them. I have videos on them, watch them, and I guarantee you'll be able to understand them. It has nothing to do with whether these things are hard. It has everything to do with the fact that you just didn't understand it when it was taught, or when it was being taught to you. The picture was not painted so well. That's why you're finding things complicated. So with that being said, in case there are any issues regarding these numbers that we have done that you feel need more light, simply let me know, and I'll be able to send links to videos that I have recorded earlier that explain some of these topics in full, in a very simple, systematic manner. And if I've not yet done that topic, I'll be able to expound more on it and teach it, and bring the sun closer, or shed more light on the matters. Otherwise, mathematics is quite easy. So with that being said, this session on fractions and decimals, past paper questions on UNEB ends here, and next time we shall be looking at another topic.